For the last lesson in this unit, we want to look at the base change formula, and here's why we're looking at those buttons. Let's discuss this problem we saw earlier. When we saw it earlier, we changed from logarithmic form to exponential. Remember, we have a base of 3. The logarithm is my exponent, the y, equals 5. So remember, we discussed 3 to what power gives me 5, which we said 3 to the first was 3. That's too small. 3 squared was 9. That's too large. 5 is somewhere in the middle. So when we punch it in, we're hoping for somewhere like 1.3. But the problem is, if you punch into your calculator log 5, it gives you something crazy like 0.69897, some horrible never repeating, never in decimal, but it's nowhere close to that 1.3. Reason being, when you punch log 5, that's assuming you're saying log base 10. What you're saying is 10 to what power gives you 5. And that's the number. If you plug in your calculator 10 to the power of 0.69897, within rounding, that's going to give you 5. We're looking for a base of 3. Some calculators can do it. Most will not, even those big fancy graphing calculators. So we have what's called the base change formula. If we have a base, anything other than the only bases we like are base 10 and base E. Those are the ones that we have a button on a calculator. We have the log button. We have the natural log button. Anything else, unfriendly. And that's why we have this formula. We can change it to say log base anything we want. The ones we're going to pick are 10 and E. Log base A of the argument is the argument in your numerator. Divided by log base, we're changing the base. So it's going to be the same base of the base becomes the argument of your denominator. And here's the way we're able to apply this. We asked for log base 3 of 5. There is no log base 3 button on our calculator, at least most calculators. So what we could say is log base, let's change it to 10. 10 because log base 10 is that log button of 5 divided by log base 10, just keep it the same, of 3. So what we're actually punching into our calculator is log 5 divided by log 3. And when we punch into our calculator, what we get is 1.46497. Never repeating, never ending. But that's pretty close to what we expected, right? We expected 1.3. That's that number. That's that number that if I take 3 to the power of 1.46497, within rounding error, that's what's going to give me 5. That's what we're trying to find here. That's how we're able to use those buttons on our calculator to set it up with a base that isn't on the calculator. Remember what else we could have said was, if you want to call it log base E of 5 divided by log base E of 3, remember log base E is, if I were to put ln of 5, natural log of 5, natural log of 3. And when you punch that in, what you're going to notice is I get that same 1.46497. Now be careful plugging this in. Most calculators start the parentheses. So what you need is natural log of 5. You need to end the parentheses and then divide it by natural log of 3 and then in parentheses. That's how you're probably going to want to enter it into your calculator.